Today's lesson 8.2, quadratic functions in standard form. We're going to go ahead and break this up into two lessons. Terminology and line of symmetry, vertex, minimum, maximum, and parabolas are key today. Biggest thing is your equation right here. F of x equals ax squared plus bx plus c. A is not equal to 0. If a were 0, you would have 0 times x squared, and that would get rid of your x squared, so it would not be a quadratic function. You need to remember this standard form, ax squared plus bx plus c. It will be key today. Know the places where a, b, and c are. A is next to x squared, b is next to x, and c is your constant. We know that the graphs are going to form a parabola. When it curves up, a will be greater than 0. Again, remember where the place of a is. When a is less than 0, it will curve down. Other terms that we need to become familiar with is line of symmetry. Line of symmetry is going to be pivotal when we start graphing these without setting up a table. What you need to remember about a line of symmetry is basically it divides the parabola in half. It's a mirror image. There's an equation for this. To find the equation of the line of symmetry, it is x equals negative b over 2a. X equals negative b over 2a. Once you find the line of symmetry, you're able to find the vertex. The vertex is a point on the parabola where it intersects the line of the symmetry. The vertex is the minimum or the maximum of the parabola, depending on if it curves up or curves down. So it is a point, it is an ordered pair. In order to find the coordinate, you're going to use what you found for x for the line of symmetry. Remember, here's that equation. That's just showing you whatever you get out for this equation, that is your x value. Once you find your x value, you substitute into the original equation, whatever that may be. Substitute in for x to solve for y. A max or a minimum value would just be the lowest point on the graph. It's the vertex of a parabola. The maximum would be obviously the highest point on the graph. Again, the vertex of a parabola. On page 2 of the A2 notes, the concept summary, this here is a great tool to look at. Notice it has the line of symmetry for you, how to find the vertex, how to find the max or min value. It also brings in how to find x-intercepts like we did in 8.1. We'll come back to that when we start graphing following the day 1 lesson. This will be on day 2. It also has how to find the y-intercept. Other things that you'll find today are the domain and range. And we've covered how to find domain and range. Domain is obviously your x values and range your y values. So this would be a good tool to look back at as well. For your first example, you need to, in example 1, you have the equation y equals x squared minus 4x plus 5. If we talk through this one real quick, the a value, remember, is out in front of x squared. The value out in front of x squared is 1. The b value, negative 4. And your c value, 5. In part A, it says, write the equation for the line of symmetry. Notice, here's what the graph looks like. Y equals x squared minus 4x plus 5. We need to find the line of symmetry. Well, if you find the line of symmetry, remember, it's going to mirror it. And if you had that line of symmetry would come right down here. Here's where it's going to mirror it, where it meets that vertex. So you'd have x equals 2. That's just by looking at the graph. You also need to know how to use that equation to find the line of symmetry, and that's what we're going to work through here. Remember, at any point in this lesson, if I'm getting ahead of myself here, go ahead and pause to catch up. So the line of symmetry. The equation, if you look back, or actually on top on the concept summary sheet, here's your equation for line of symmetry. Remember, it is an equation. Equations have equal signs, so you are solving for x. In for the terms here, b is -4. So we have a negative out in front of here. So we are going to fill in negative, and then we have -4. Here's the first negative, holding that negative sign. And remember, when we use substitution, we like to use parentheses. So in for b, we have -4. On the denominator, you have 2 times a. A is 1, so substitute 1 in for a, and you wind up with this as your new expression. When you solve it, negative times -4 is positive. So you get a +4 as your numerator, and on the bottom you have 2 times 1, which would be 2. So you would have 4/2. 4/2 reduces to 2, which we had already found out here. So your line of symmetry, LOS, line of symmetry, would be x equals 2. Remember, it is an equation. You cannot just write it as 2. It has to be x equals 2. It is the equation right here for this line, this vertical line. In B, we're going to find the vertex. Remember vertex, look at your concept summary. In order to find the vertex, remember the vertex is a point. You've already found half of the vertex by doing the line of symmetries. So the x value is 2. Now to find the y value, you simply substitute 2 into your original equation to solve for y. Here is your original equation. Y equals x squared minus 4x plus 5. Right up here from example 1. Substitute 2 in for x. So when we do our substitution, we plug 2 in for x. 2 is squared here, minus 4 times x plus 5. Notice where I use substitution, I use parentheses. So we go ahead and solve this here. 2 squared is going to give you 4. -4 times 2 is -8 plus 5. When you do your computation, you would find out that y is equivalent to 1. Now, the vertex is an ordered pair, so we'll write it as an ordered pair or coordinate. We know our x value by finding the line of symmetry was 2. Your y value is 1. Therefore, your vertex is 2, 1. Remember, the vertex is going to be a min value or a max value. In this case, on the graph, it would be right here. Notice that your x value is 2, your y value is 1. This would be a minimum. It is the lowest point on this graph. You also need to state your domain and range for the function. Your domain deals with your x values. So if you look at this graph, this parabola is going to continue on forever in this direction and that direction. So your x values are going to be all real numbers, which it states in the key concept. All parabolas will have all real numbers for your domain. Your range deals with your y values. Well, if you look up here, here's the lowest point on your graph, which is y is 1. So all these values for y values are greater than 1. And it states also in your concept summary that if the a value is greater than 0, you're going to write your range as y is greater than or equal to the y coordinate of the vertex, which in this case was 1. So we have y is greater than 1. In example 2, you're not going to have a graph here to compare to figure out that line of symmetry. So when there's no graph present, you need to jump right into using your equation for the line of symmetry. And here's that equation again. Substitute things in correctly. Remember the standard form, ax squared plus bx plus c. Notice that the a value is actually -1 here because it's -x squared. So let's go ahead and substitute in. B value is -8. So we have negative, holding that negative sign, -8 on the top. On the bottom, the denominator, we have 2 times -1. Negative times -8 is 8. 2 times negative 1 is 2, negative 2. So when you solve this, simplify it, 8 divided by negative 2, you'd wind up with negative 4. Remember, line of symmetry, it is an equation, you cannot just put negative 4. So we would say x is equal to negative 4. Coming down to solve for your vertex. Vertex is a point. Remember, we have half of it done right now. We know our x value is negative 4. To solve for your vertex, use the original equation. Substitute what you know, that is the line of symmetry. The x value is negative 4. So we substitute into our original equation. Okay? Notice, and this is normally where mistakes happen, negative, negative. Hold that negative on the outside. Substitute in for x. We know x is negative 4. We square it. Minus 8. Negative 4 is in parentheses again for substitution. Minus 13. Do your computation. Negative 4 squared is negative 4 times negative 4, which would be 16. Times the negative on the outside is negative 16. Plus negative 8 times negative 4 is a positive 32. And then we subtract 13. Do your computation to solve for f of x. Remember, function of x basically meaning y. And we find out y is equivalent to 3, giving us our vertex negative 4, 3. If you notice question C, it's misworded on your guided notes. It says find the y-intercept. Let's go ahead and change that to state the domain and range for the function. Again, it is a parabola. We know that the parabola, whether it curves up or curves down, and if you look at the equation, f of x equals negative x squared minus 8x minus 13. It is a negative, therefore your parabola is going to curve down. Remember, it's in front of the coefficient in front of x squared, so it will curve down. It still has all real numbers. We know that your vertex is negative 4, 3. So if I actually plotted that on the graph, it would look like this. Your x value is negative 4, so let's just kind of pretend we're moving over 4 here. 1, 2, 3, 4. Negative 4 up 3. 1, 2, 3. So your vertex would be somewhere in there. And remember, it is negative, so your graph is going to curve down. Not getting this smooth curve, but your graph would curve down on both sides, creating the parabola. We know that this value here was 3, so your range deals with your y value, and since it's curving down, it would be y is less than or equal to 3. And if you flip back to your concept summary page, you would find out that your range depends on a. And remember, in this case, a is less than 0. So your y is less than or equal to your y coordinate of the vertex. In this case, that would be 3. So y is less than or equal to 3. The last example for the day, y equals negative 2x squared plus 4x plus 1. This is a negative 2, so negative 2 means that your graph is going to curve down. When it curves down, you're going to create a max value. Just to prove it to you, here's the curving down. Your max value would be right here. So the max would have a max value because it curves down. So you would say it has a max or maximum. And B, I want you to go ahead and solve for the vertex. Now, in order to solve for the vertex, you need to find the line of symmetry first. Find your x value. I'm going to go ahead, pause it here, work through it, find your x value. When you work through everything, you would find out that your line of symmetry, x equals 1. Pause it and work through the rest. Vertex is 1, 3. Domain, all real numbers. And your range is y is less than or equal to 3. This concludes day 1, 8-2 lesson.